Hello. In this video I'm going to introduce the data types that are built into the C# language. C# is very different from Lua and Python. It is a strongly typed language, which means when you make a variable or specify that a function takes a parameter, you have to say what type of data that variable is going to hold. So we're going to talk about the types of variables that are built into the language. So the simplest one is the bool type. That's our Boolean variable. It just means it stores true or false. And true and false are already predefined in the language, just like they were in Lua. So if you want to make a variable called game over that stores a true-false value, you have to say that it stores a bool. So in this example here, bool game over equals false. What I'm doing here is I'm saying, make me a storage space for one bool, and I'm going to call it game over, and I'm going to set it to false. So take the value of false and stick it into the box called game over, which is storing bools. If I tried to store something else in game over, like a picture or a sound or something else, that wouldn't work, because I've said game over is a variable that can only store a bool. So that's our simplest type of variable, just true or false, yes or no, right? But true or false are built into the language. Moving up from that, we need to store numbers lots of times, and these are the different types that the language provides. We've got byte, short, int, and long, and they can store values of varying sizes, but the one we're going to be using all the time in this class is int. That's just a 32-bit integer, and that can store numbers plus or minus 2 billion, which is plenty big for anything we're going to do. So if you wanted to make a variable called score that was going to be set to 100, you'd have to say int score equals 100. Make me an integer variable called score and copy the value 100 into it. Set it equal to 100. So again, when you make a variable, you have to say what type of data that variable is going to hold. All right, what about numbers that have a decimal point in them? Those are called floating point numbers because the decimal point can float around. The one we're going to be using most of the time is float. That is a 32-bit number that can store a number with a decimal point, like 3.1415. That's a number with a decimal point. That's a float. If you needed a really big number that had a decimal point in it, well, that's a double. That's 64 bits, and the decimal type is used for financial calculations. We're not going to use that in this class, but you might use that at the college level, or if you're ever doing anything that has to do with money. So that's 16 bytes long, or 128 bits. So that's a double. It's a quadruple. I mean, really. So the one we're going to use primarily is float, though. We may end up using doubles at some point, but floats are smaller, means they're faster to compute stuff with a double. So here's an example of declaring a float. So I'm making a variable called f. I'm saying, give me enough storage space for one float. I'm going to call it f, and I'm going to put that value into it. And notice I've had to tack on the letter f, and that tells Visual Studio this number is a floating point number. It's 32 bits long. If I don't put the f there, Visual Studio will yell at me because it'll think that it's a 64-bit number. So when you specify a number literally like that in your code, you have to put f after it if it's a floating point number, if it's a float. So, and if you were going to make a double, then you don't need any sort of suffix on it, because the Visual Studio will say, oh, okay, that's a double, and you're storing it into a double. So again, here I've made a variable called d, and it can store a double, and I'm putting that value into it. So reserve me a box big enough to hold a double called d, and stick that value into it. So there's an example of using a double, and that's also a number with a decimal point, but it's bigger. It can store a bigger range of numbers because it's 64 bits long, not 32 bits long. And all right, moving on. What else have we got? So again, the decimal type is just for money. We're not really going to use that here in game development. And then this is all kind of stuff I'm going to skip. What about characters, individual letters? There's a data type called char, or char. There's a religious war over how that's pronounced. So if you just need one letter, that's a char data type. And notice when you are working with chars, you are using single quotation marks. Single quotation marks means this is a character. Double quotation marks means it's a string. That's something different. So if you just have a single character, that's a char, and you can set it equal or test it to compare it against another character using the single quotes to specify the character. So there you go, there's characters. That's just one letter of the alphabet, or one symbol. And they're actually 16 bits long, or 2 bytes long, and that way they can store a huge number of symbols, as opposed to like older systems which can only store 256 symbols. So there it is, char, the char data type. And then also equally useful, or more useful, is the string data type. So if you need to store somebody's name, the name of a city, some text, that's a string. And strings are called strings. Think of them as a string of characters, right? It's just a string of letters all bound together. So and that is specified using double quotes. So notice in the last example we had a single letter, and that was single quotes. Here we have more than one letter, so we have double quotes. This is a string. So I've made a string here called S, and S contains this is a bunch of characters. So that's another very, very frequently used data type. The string. Strings are just text. You can concatenate strings together using the plus sign, just like you can in Java. So this doesn't mean add these two strings together, it means stick them together. Take the second string and stick it on the end of the first string to make a bigger string. And then I can write that out to the console. So in Lua, you had to do a lot of weird stuff when you were manipulating strings or putting strings and numbers together. C# is very nice. It's just kind of like Java. You can just use the plus sign to tack a whole bunch of things together. And if you wanted to get a character out of a string, you can use the square brackets to go in and specify which character you want. But just keep in mind, in C#, indexes start at 0, whereas in Lua, they started kind of wherever you wanted them to start, and usually 1. So keep in mind, when we're in C#, indexes start at 0. But what this means is go into the first character of string S and convert that thing to a string and print it out. And it would print out the letter S. Because the write line function here takes a string. It prints out text. So I can't print out a character, I've got to convert it to a string first. We'll skip this, skip this, skip this. All right. And skip that. Okay, if you want a variable to be not changeable, it's like once you've declared it, you're done. That's it. You can never change it. Like pi or something, that's a constant. It's never going to change. Then you can put the word const in front of something. And generally, I like to make constants capital. And that just tells me, oh, that's a constant. Don't mess with it. So here I've made an integer variable called max health, and I've set it to 100. And I've put the word const in front of it, and that just means this is a constant. You cannot change it. So I could never change the value of max health later in my game. That's a fixed number. It cannot be changed. We'll skip read only. And sometimes if you need to convert back and forth between different data types, well, sometimes you will have to convert back and forth between different data types, and there is an object in the language to help you do that. That is the convert class. So if you look up the documentation for the convert class, you will see that it has all sorts of functions for converting one type of data to another type of data. So if you need to convert a string to a float, you can do that. If you need to convert an integer to a double, you can do that. If you need to convert anything to a string, you can call its toString function. Everything in C# has a toString function built into it. Everything in C# is a descendant of system.object, and system.object has a toString function. So even the number 5 has a toString function, which seems kind of crazy, but it's true. And we can skip all that. All right, so I think I'll leave it there. If you have any questions on data types, just ask, but keep in mind you're going to have to be a little bit more specific writing your code than you were in Lua. In Lua, you could just make a variable called x, and 1 minute it's a floating point number, the next minute it's somebody's name, the next minute it's an object. That doesn't work in C#. When you make something an integer, it's always going to store an integer. All right, well there you go. We'll keep talking about this in future videos, but you need to know this stuff: ints, strings, bools, and floats. those are going to be things we use all the time. So know what those things are and what they're for.